I'm going to go over this supplement 6, statistical quality control using Excel function. For whom cannot use Megastat to develop control charts. Skip this part. Already we did. Attribute and variable. Attribute. This is categorical data. If we have categorical data, and then we call that data as an attribute. And then numerical data, such as weight, volume, size, and so on, then we call that variable. If data is attribute, such as defect, the number of defect, percentage or probability, then we develop p-chart, probability chart, using this formula to define UCL, upper control limit and lower control limit. By the way, SP is standard deviation of that variable data, and P bar is probability of total sample. Okay, open the example data. It looks like number of defects out of 300 sample, and then sample size is 300, and then the number of sample is 10. This one. Copy and paste the formula here. Okay, to use this formula, we need p-bar. P-bar is bring up this one too. Total number of defects from all sample. So that will be equals sum of defects, total defect, and then number of samples, 10, and then sample size is 300. So that is the same as equals sum of all sample. So P bar equals, I will type P bar, P bar equals total number of defects, that one, so equals total number of defects divided by, this one is the total number of sample, that is 3000, so divided by, 3000. So P bar is 0.030333. So we have a P bar here, and then plus Z score, go back to G-score, if company use the 3 sigma quality control, then the inside of acceptance area is 99.73%. So it's like doesn't work. It's like the normal distribution, and then inside between upper limit and lower limit, this inside is 99.7%. Then this boundary G-score is 3. So use 3. And then we need standard deviation. Standard deviation is this one. So standard deviation equals square root of p bar. We got p bar here, and minus 1 p bar divided by n. This one is a sample size, not total sample. Sample size of each sample. So I will type standard deviation p equals type equal, then we need this function square root. So square root, then this function sqrt, and we need one more parenthesis p bar minus p bar times parenthesis 1 minus p bar. This is, take one more parenthesis, divide by n. This n is 300. So you can type just 300. And just I need one more parenthesis open. Let's see this one. Okay, this is divided by this one. Maybe the number of parentheses is not right, but anyway, you can fix. So standard deviation is 0.009901. That is right. So we can define upper control limit. Upper control limit equals, then that is equals p bar, this one. So p bar, this one. So click this, plus G-score is 3 because we determine the G-score from the control limit 3 sigma, then 99.7. percent inside acceptance area, and times standard deviation, this one, enter. And then log control limit equals, and then equal here again, p bar again, log control limit is p bar minus, so minus, this score is 3 times standard deviation, this one. We have UCL and LCL, upper control limit and lower control limit. So we can draw P chart using this Excel chart. To do that, we need data. So first, upper control limit, and we need a lower control limit. I will show the chart, develop the chart, what data we need. So we need the upper control limit, lower control limit, and then I will indicate the mean. So we need the upper control limit, lower control limit, and each sample's probability. So we need the upper control limit, lower control limit, and then P bar. And we need P for each. By the way, we need P here, probability of each sample. So that is equals number of defect divided by sample size. Copy all the down. Then I will use yeah. So this one, just copy. And when you copy and paste, if we use a function, then if we copy one and then move like this, then maybe the cell number change and then the result change. So when you copy numbers using functions, then paste. If we want to paste the same number, then just copy only number value. Then UCL here, this one, so equals UCL. Then we will use this cell all the way down. So change this cell as absolute value. To change absolute value, this one absolute value, type F for function key, then $C$17, enter, and then copy this value all the way down. Then LCL, this one, okay, so equals LCL, and then make it absolute value, enter, and copy all the way down. Then we need a P bar, this one, so equal this P bar, then make it absolute value, enter, and it's all the way down. Okay, now I like data 3 decimal, okay, 5 decimal point maybe. 5 is enough, okay. Then specify data range, including labels, to draw graph. So click insert, and then I will draw this P chart using line chart. So click this one, B, and then this one. So we can change this title P chart. So we draw P chart using Excel. Go. Okay. So upper control limit, low control limit, and then average, and then probability of each sample. It looks same as already developed chart, the example chart. So all probability of each sample inside between upper and low control limit. So this process working fine. Look the same. Okay, next one. X bar and R chart. If data is variable, numbers, like volume, heights, lengths, and so on, then we can draw X bar and R chart using this formula. If we know, or if we can get a standard deviation of that data, then using this formula, or we can use charts, this chart. If we don't know standard deviation, then we can use this chart to develop X bar and R chart. Then the value A2, D3, and D4 from the chart. So I will use this formula. Open the example data. Example data 2. Make it a little bit bigger. Okay, so we need a formula. Bring up the formula. X chart. This formula. And for R chart. Upper control limit and lower control limit for R chart. Okay, sure. So we need double X bar. This one is sample mean of mean. So we need a sample mean X bar. I will type X bar. So X bar is average of this sample. So equals average of this sample. So from B, C, D, E, F, and then enter, and then copy all the way down. So they are B bar, and then I will type average. So average of average equals, again, average of average. So we have X, double X bar, and then we need A, 2, D4, and D3 from the chart. From the data set, each sample size is 1, 2, 3, 4, 5. So we need A2, D3, D4 for sample size 5. So I will bring them. Oops. Change. So that is A2 is 0.58, D3 is 0, D4 is 2.11. Change the screen. I need A2, D3, and D4. From the chart, when sample size is 5, and the A2 is 0.558, D3 is 0, D4 is 2.11 from the chart. So we have and then now we need R bar. R bar is R is range. Range is from the data, the largest minus smallest. So for sample 1, 10.6 minus 9.9. So we need R range. Range is biggest minus smallest, or maximum number minus minimum number. So I can use Excel function max, and then we need from where. So max from this data set minus minimum. So minimum number from this data set So 10.6 minus 0.99 is 0.7. And then we can copy and paste all the way down. And then R bar is average of R range. So this one we already did here, average or this range. So just copy and paste by moving. So we have X double bar, we have X2, A2, and then R bar here. So we can, I will move this one a little bit away. So UCL for X bar equals X double bar, this one, so equals, type equals, and then X double bar plus A is 0.58. So we can you can type now 0.58 or just click this cell times R bar, this one. Okay. So for X bar chart, upper control limit is 10.553. And then we need an LCL for X bar chart equals same formula but minus here. So double X bar equal sign first equal double X bar minus A2.58 times R bar. So low control limit is 9.86. Okay, we did that. And then we need upper control limit for LR range. So UCL is automatically R. That is this one. D4, so equal D4 is 2.11 times R bar. This one, enter. And then low control limit for R chart. Oh. Yes. Type equal. And then D3 is 0 times R bar. So we have upper control, low control limit for X bar chart, and then upper control limit, low control limit for R chart. So we can draw. I will show developed chart. So we need upper control limit, lower control limit, and mean, and then each samples X bar, and then upper, lower, mean, and each samples R bar, R, the range. So we need here to draw a chart. We need first upper control limit, x bar, and lower control limit, x bar, and then we need x double bar, let's say double bar, and we need x bar. Okay, upper control limit, this one, so equals this cell, and then we will use this one all the way down, so make it absolute value by typing F4 function key, enter, and then copy all the way down. Then LCL equals this, copy all the way down, and then x bar, x double bar, this one, so equals x double bar, make it absolute value, enter, copy all the way down, and then x bar of each sample, this one, so copy, I will copy, then paste, only number, and this one is okay, 4 digit, 5 digit. Okay, then all 5, it's okay. Then we need data for R chart. So UCL R, UCL or LCL R, and then R bar. Then we need R for each sample. So this one is here, this one. So equals this R, absolute value, enter. Okay. Then LCL is 0. So you can type 0 here, and then paste all the way, and then R bar is this one, so equals this one, absolute value, enter, then R here, so copy, okay, we are ready to draw X bar chart and R chart. Okay. First, specify input range, and then insert line chart. Now we can type X bar chart. Now we need R chart, specify input range, and this one, move, chart name is R chart. Okay. So we can draw X-bar chart and R chart using Excel function like this. And then this one is now the same. Okay, next one, C chart. C chart, similar to this P chart. The data is attribute, categorical data, but if we don't know a sample size, instead of sample size like a period, during a day, during a week, or in an hour, something like that, then how many? That case, we can use, and you can draw C charts. So C chart, upper and lower control limit, C bar. This is the average of the number of happen appearance, plus minus 3. The same. If the control limit is 3 sigma, then Z score is 3. Then inside acceptance area is 99.73. Okay, C bar is the number of total defect divided by the number of sample. Okay, so open sample data, example 3. Okay, here, first day, number of complaints, 3, 0, and so on. So develop C chart. Just a moment. I need that one. Just a moment. Need the formula. What can I do? Just to show you, because I cannot, I don't know why, but I cannot copy that formula. Just bring up here. Okay, we need this formula. Then C bar, we need C bar. C bar is the number of defects, total defects, and divided by the number of sample. So I will type C bar, that is mean. So that will be equals average of this. So C bar is 6. And plus minus 3 square root of C bar. So upper control limit C equals C bar, first the upper control limit plus 3 times 3, that is 3 sigma quality control limit, and then times square root QU square root of C bar, and then we need the lower control limit for C equals, oops, the same. This one equals C bar minus 3 times square root of C bar this one result is negative, but for this C chart, lower control limit cannot be negative, so it's 0. Then to draw the control chart, again we need UCL for C, LCL C, and then mean, that is C bar, and then we need C each complaint of each sample. So UCL, this one, so equals this absolute value, and copy all the way down 9, and LCL equals negative, but now I will use 0 because now lower control limit cannot be negative, so equals 0 absolute value, and C bar, this one, so equals C bar absolute value, enter. Then C is there, so copy, paste only number. Okay, we are ready to draw, develop C chart. So specify, insert, line chart, change name, C chart. So this one looks the same. This. So you can draw or develop control chart using Megastat and using this now Excel function. Okay, that's all. Hopefully can use Excel instead of the Megastat to develop XBAR control chart, quality control, process control chart. Okay, thank you.